Bio-1 students, Mr. Yachts again. Let's kind of continue on with notes. I know we're doing some notes for e-learning, and I might be just a little bit out of sequence, but after today, the whole chapter will be online. So virtual students, you'll kind of have to backtrack a little bit, maybe finish up your notes over the weekend here. So there are three types of RNA, and you guys probably have heard of these before. We use a little letter and then capital RNA. We have messenger, which is little m, big RNA. It carries a DNA code from the nucleus into the cytoplasm. So basically, we talked about this earlier in notes. The problem we have is we have this DNA, the blueprint, is trapped in the nucleus of a cell. It can't leave. But yet we're building the proteins at the ribosomes outside the nucleus. So we have to get the blueprint to the building site. You know, I talked about how when I built my house, I had the blueprint in Wisconsin. The building supplies came out of the UP of Michigan, and I had to get them in northern Indiana together. Okay, messenger RNA brings the blueprint. So we talked about how we build an exact copy of DNA, which is replication. We're going to do a very similar process called transcription, but we make messenger RNA. And by the way, just a little side note, this is how they made the COVID-19 vaccine, is using an mRNA science. So we'll talk maybe more about that sometime too, okay? So that's one thing we have to do. We have to get the blueprint. What about the building materials? How do we get them there? That's where transfer RNA comes in, okay? Transfer RNA, tRNA, goes out into the bloodstream where we've digested food and broken that food down into amino acids. They find these amino acids and they bring them to the messenger RNA. Now, this makes sense. There are 20 varieties of tRNA. Why? Because how many amino acids do we have? You probably remember this from chapter 2. From chapter 2. We have 20 because all proteins, millions of proteins, are made of the same 20 amino acids. So it makes sense that I got one transfer RNA for every amino acid so they don't get messed up and pick up the wrong one, okay? And the third thing we got to have to build a protein is something to make sure everything matches, and we put together and we build it. That's where our RNA comes in, okay? It is the site where the polypeptide chains are assembled, and it analyzes and makes sure everything is paired up like it should be, all right? Okay, a little bit other background information you need to know before we get into transcription and translation is the three-letter code of RNA. So there was a very smart scientist many, many years ago named Har Kurata that was at the University of Wisconsin, and he cracked the code. It was a big deal. He won the Nobel Prize. It really set genetics forward. We've been going crazy ever since. And what he figured out is that the RNA code is grouped into three-letter combinations. Now, we're going to put this on paper, but that's not what the body does. It looks at how it's chemically bonded together. But we put these in groups of three. Triplet means three. That's where that name comes from. And codon means code word, okay? And you'll notice there's 64 different code words or three-letter words. So we came up with this crazy thing. And don't worry, you don't have to memorize the whole thing. But it's just putting three bases together. UC, uracil, cytosine, adenine, guanine. Same thing across the top, same thing down the side. And you'll notice, right, that we only have 20 amino acids, but we have 64 codes. So there's some codes that don't code for anything. We'll talk about these in a minute. And then there's some that have 6 codes, some have 2 codes, some have 1 code. It just depends on how much we use these amino acids in the body. And some of them are repetitive. But what you're going to find out is no 2 different ones have the same code. Okay? Body's got to keep that straight. All right? Now, how this works, so a little background, okay? What you need to understand when we get into transcription is there's 4 codes I want you to know. So there's 64. I'm only going to have you know 4 for the test next week. All right? Every protein, blood, skin, muscle, bone, whatever, they all start with AUG, which happens to code for an amino acid called methionine, okay? So think about English class. You learn early on in English class that I have to show in a sentence where I start a sentence and where I end a sentence so I don't have run-ons and it doesn't get all jumbled up and all confusing, right? So this would be your start point, your capital letter in a sentence that you start your sentence with, right? And then you have to have an end point, a question mark, an exclamation point, a period. That's where these three come in: UAA, UAG, and UGA. They are what we call stop codons. What you'll notice from this little thing here is they don't code for an amino acid. So as we're building a protein, most proteins are about 100 amino acids, which is 300 codes. Okay, it's going to go along until it hits one of these stops. Doesn't matter which one, and then that's when it knows I'm done. I ship that protein out, and it becomes blood, skin, muscle, whatever. Okay. Now, sometimes it's called a mutation, right? Sometimes it messes up. What if I get a stop sign put in too soon? That's when people get born with partial hands, partial arms, partial legs, things like that. Okay, so we'll talk a little bit about that hopefully later on too. All right, so that's basically what those four are for. So kind of memorize those. And here's the deal. Again, just a little background. And then this is where I'm going to pick up notes and finish up notes with that fourth day there. Is proteins are made up of long chains of amino acids. An average protein is about 100 amino acids long. Amino acids may have more than one code. You saw some of them had 6 of them, but no two different ones have the same one. They all start with methionine, AUG, and they all stop with one of the stop codons. Stick that in your brain, good background information. We're going to pick up with this and finish up notes and say, here's how we make a protein. That's what I want you to understand and put in your foldable, and we'll take a test on. All right. Hopefully that makes sense. Have a great day, and we will see you later.